Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at ASA Solutions. We'll be discussing ASA Firewall Models, Cisco ASA Next Generation Firewall Appliances, Advanced ASA Firewall Features, Firepower Series, Cisco FTD Threat-Centric Next Generation Firewalls. We're going to look at a review of firewalls and network design, ASA firewall modes of operation, and finally, ASA licensing requirement. This episode is part of my series on network security for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. The Cisco ASA with Firewall Services family of products provide dedicated firewall services in one device. Now, these are what we call next generation firewalls, and they deliver integrated threat defense across your entire attack continuum. They combine here ASA firewalls with the source fire threat and advanced malware protection in a single device. These include a number of different model lines from Cisco. We have the Cisco Firewall 1000, 2100, 4100, and 9300 series Cisco Firepower firewalls. Now, the biggest difference between the models is the maximum traffic throughput handled by each model and the number and types of interfaces. Cisco also supports the virtualization of computing infrastructure by taking advantage of increased power availability of modern x86 servers. Now, the Cisco Adaptive Security Virtual Appliance, also known as the ASAV, these bring the power of the ASA applications to the virtual domain. Now, they provide suitable solutions for customer needs. The Cisco ASAV is available in 5 different models. And so we have the ASA V5, V10, V30, V50, and V100. The focus of this episode will be on the ASA 5506X, which is designed for small businesses, branch offices, and the enterprise teleworker implementations. This is not a virtualized machine. This is one of the little devices you can mount on your desktop or something like that home user can use. Businesses of all sizes must be vigilant when protecting access to valuable data against new, sophisticated cyber attacks. Traditional security solutions are insufficiently secure, overly complex, and often costly to manage, leaving businesses at risk. Cisco has created the next step in firewall security, using the trusted hardware of the Cisco ASA technology with Cisco's industry-leading threat protection software. So they've combined these two into the Cisco ASA Firepower services. This creates a true threat-focused next-generation firewall, protecting businesses against the entire attack continuum. Cisco ASAs with Firepower services deliver what we call threat-centric security. Whether you're protecting a small to mid-sized organization, remote office, or even a distributed enterprise, the solution integrates precise application visibility and control with leading advanced malware protection and next-generation intrusion prevention capabilities. These threat defenses complement the class-leading stateful firewall, VPN, and URL filtering technologies, delivering integrated threat protection from a single device. Simplified management options for a single or multiple deployments give security teams intuitive dashboards, actionable intelligence, and detailed reports for comprehensive insights and analytics. Leveraging this awareness, the system dynamically responds to new threats and automatically adjusts as your network changes and grows over time. The Cisco ASA with Firepower services fits smoothly into your existing environment, reducing cost and complexity. The highly scalable, tightly integrated solution lowers the total cost of ownership by simplifying your security architecture and providing a single vendor support. The ASA with Firepower services desktop models are tailor-made for small to mid-sized businesses and the distributed enterprise. They come available in both wired and wireless configurations. This next generation firewall runs silently and features enterprise level security technology in a small footprint form factor. The Cisco ASA with Firepower Services provides a revolutionary approach to threat defense through an adaptive and flexible solution that is leading the way in next generation firewall security. A single ASA can be partitioned into virtual devices. Here we have one single ASA, and it's covering 3 different LANs. And each of these virtual devices, they are called a security context. So we have security context A here, B, and C. So one physical device with virtual partitions, virtual devices called a security context. Each context is an independent device with its own security policy, interfaces, and administrators. Multiple contexts are similar to having multiple standalone devices. Many features are supported in multiple context modes, including routing tables, firewall features, intrusion prevention systems, and management. Some features are not supported, including VPN and dynamic routing protocols. 2 identical ASAs can be paired into an active standby failover configuration to provide device redundancy. Both platforms must be identical in software, licensing, memory, and interfaces, including that security services module, also known as the SSM. Here we have ASA. This is the primary active forwarding device. Traffic leaving PC1 here takes the preferred path using ASA1. So it goes through ASA1 out to the internet, wherever it's traveling to. ASA1 and ASA2 monitor each other using LAN failover link. So what they do is they have a connection between them to provide this failover link. If ASA1 fails, ASA2 would then take over, become the active one immediately. So immediately it sees that ASA1 failed, and it then takes over as the primary active ASA. The ASA provides optional granular access control based on an association of IP addresses to Windows Active Directory login information. When a client attempts to access the server resources, it first must be authenticated using Microsoft Active Directory identity-based firewall services. These services enhance the existing control and security policy mechanisms by allowing users or groups to be specified in place of source IP addresses. Identity-based security policies can be interleaved without restriction between traditional IP-based rules. The ASA uses advanced inspection and prevention modules. Now, these modules, you can think of them as cards we insert. Different modules can have different capabilities. Anti-malware capabilities can be deployed by integrating the Content Security and Control module. The Cisco Advanced Inspection and Prevention Security module and the Cisco Advanced Inspection and Prevention Security Services card deliver protection against tens of thousands of known exploits. Cisco has introduced a new line of next generation firewalls. Now, these next gen firewalls combine their proven wirefall technologies with SourceFire advanced threat and malware detection capabilities. These next generation firewalls consolidate multiple security layers into a single platform, eliminating the cost in buying and managing multiple solutions. This integrated approach combines best-in-class security technology with multi-layer protection that is integrated into a single device. The Cisco ASA 5500X with Firepower Services, they're part of this new Cisco next generation firewall. Designed for small to medium-sized branches, the ASA 5500X merges the ASA 5500 stateful firewall features with some advanced threat and malware detections, like next generation intrusion prevention systems, advanced malware protection, AMP, and application control and URL filtering. I hope you're liking this episode on ASA Solutions. If you have the time, please leave a comment and let me know what you think about ASA Solutions. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. A lot of people ask, what does it mean to have a threat-centric firewall versus a regular plain old firewall or a next generation firewall? The common thing about stateful firewalls or even next-gen firewalls on the market is that they all start with being centered on the access policy. If you look at basic stateful firewalls, you have things like IP addresses and TCP UDP ports, and that's pretty much how you write your policies. It's very basic, very network centric. When you create a next-gen firewall, what a lot of vendors do, they add things on top of the basic policy table. They add things like URL categories and URLs in general. A lot of vendors do add application identity into the equation. More abstraction is also better. User identity is a big thing. You add all these different things, and now you've got to call your firewall a next generation firewall. Mind you, all of this still centers around the access policy, and this is only applicable when you first create the connection. When we create the connection, the packet goes through the access policy, something is allowed or denied. It's relatively static, it's relatively in place there for the duration of the session. Does Cisco do this type of policy enforcement in their threat-centric firewall for their defense? Absolutely. This is your basic policy element. They have to do it. They go a little bit further than just those basic elements. They provide you some nice integration with things like PX Grid for user identity. You not only get your names from your logging into LDAP or Active Directory, but you also infuse a lot of extra content, a lot of extra metadata from ICE, such as geolocation, type of device. That kind of granular profiling helps you build a better policy. On the application side, they have something called Open App ID, where you can define your own application signatures. You don't have to rely on the vendor alone, giving you a specific package of applications to detect, recognize, and allow or block within your policy. You have the freedom of going in there and actually designing your own application detectors and using them across your policy and reports. All of those different things done at the time of policy creation still applies for firepower threat defense. This is how they achieve close to 100% efficacy in terms of the basic permit or deny policy stage. What is different about threat-centric firewall, like firepower threat defense? Like I said, they do all of that, and they do it very efficiently. They give you additional tools to make those things happen. The fundamental architecture difference between regular firewall and next generation firewall and threat-centric firewall is that they center here. It's not the policy. Policy is something that once the connection is created, traffic starts flowing, and I would argue that most of the attacks don't try to circumvent your policy. They try to attack applications and users and other flows that are actually permitted by your policies. This is where the fun thing starts. At the centerpiece of threat-centric firewall, like firepower threat defense, we have the intrusion prevention system. So we have the intrusion prevention system and advanced malware protection engine. So at the center of our firepower threat defense, we have an IPS and an AMP engine. These two engines look at the traffic that is actually permitted by your security policy and everything like application visibility and control, user ID, AMP cloud, threat grid, even operating system fingerprinting. All of those modules, they feed into those two engines, into the intrusion prevention system engine and the advanced malware protection engine. They continuously provide them relevant data to make decisions whether to allow or block traffic that is otherwise permitted by your security policy. It's not only looking at what happens at the time of the connection created, but also what happens after that connection is created. And if it's for the duration, for how applications and users leverage your network. That is the main difference between regular and next generation firewalls and threat centric firewalls, at how you look at traffic and how you permit or deny flows, based not only on static policy, but also on the right time environment and the threats. When discussing networks that are connected to a firewall, there are some general terms to discuss. First one here is the outside network. This is the network or zone that is outside the protection of your firewall. It's basically the internet. The inside network, this is the network that is protected behind the firewall. So this is the inside of your network. This is where all of your corporate network, all your servers, all of your networking devices lie. And finally, we have the DMZ, the demilitarized zone. Now, this allows both inside and outside users to access a protected network resource. Firewalls protect inside networks from unauthorized access by users who are on the outside the network. They also protect inside network users from each other. For example, by creating zones, an administrator can keep the network that is hosting the accounting servers separate from the other networks in an organization. These three zones, the outside network, the inside network, and the DMZ, they all by default interact and permit traffic with each other in certain ways. The inside network, traffic originating here on the inside network, going to the outside network, going to the DMZ. So it's starting here on the inside, going to the outside network, going to the internet is permitted. And once again, notice the direction from the inside to the outside. Also, traffic originating on the inside is allowed to go to the DMZ. It's allowed to go to the DMZ. Traffic originating from the outside network, so from the internet, is selectively allowed to go to the DMZ. And notice we say selectively. You have to put an exception in your firewall. You have to put a rule in your firewall to allow that outside traffic to that DMZ server. And once again, the server in the DMZ needs to be accessed by the outside and the inside network. So we put it on its own network, the DMZ. And then you have to go in and configure a rule to allow that traffic from the outside to the DMZ. Our three zones also deny traffic going in certain directions. Traffic originating from the outside, from the internet, going to the inside, that is blocked. You cannot transfer data from the internet, from the outside to the inside. We can, or also traffic from the DMZ to the inside network, that is also not allowed. The Cisco integrated service routers can provide firewall features by either using zone-based policy firewall or by using older context-based access control features. There are two firewall interface modes of operations available on ASA devices: routed mode and transparent mode. In routed mode, two or more interfaces separate layer 3 networks, or what we call domains when we're talking about ASA firewalls. The ASA is considered to be a router hop in the network. So right here in our router mode, the ASA is a router hop. In routed mode, the ASA can perform NAT between the connected networks. Routed mode supports multiple interfaces. Each interface is on a different subnet and requires an IP address on that subnet. The ASA applies policies to flows as they transit the firewall. The ASA in transparent mode is often referred to as bump in the wire or a stealth firewall because the ASA functions like a layer 2 device and is not considered a router hop. The ASA is only assigned an IP address on the local network for management purposes. This mode is useful to simplify a network configuration or when the existing IP addressing cannot be altered. However, the drawbacks include no support for dynamic routing protocols or VPNs or quality of service or dynamic host protocol DHCP relay. A license specifies the options that are enabled on a given ASA. Most ASA appliances come pre-installed with either a base license or a Security Plus license. To provide more features to the ASA, additional time-based or optional licenses can be purchased. To verify the license information on your ASA device, use the show activation command. So show activation -key command, or you can use the show version command. When you use the show activation -key command, it will show you all the licensed features for that platform. Now, it's all the licensed features, whether you have them enabled or disabled. You can see over here in this center column here, that's where you can see whether they're enabled or disabled, the maximum number of something. So right here, we have a maximum number of 5 VLANs we can run on here. Failover is disabled. You'd have to buy a license for that. But we have encryption DES and encryption DES AES enabled. And you can work through all these different licensing features. It was my pleasure to provide you with this wonderful episode on ASA Solutions. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on network security for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on network security for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.